So what if I told you the single most dangerous thing in the entire cosmos isn't some colossal visible horror, like a black hole or a rogue planet?
Uh-huh.
What if it's a theoretical danger that is, currently invisible, utterly quiet, and it resides in the very fabric of our reality?
Well, it's not a threat you could ever observe through a telescope or detect with conventional instruments.
Right.
It is the ultimate fundamental instability, and its source is a single random event.
We're talking about the theoretical potential for the Higgs vacuum decay, the silent, instantaneous collapse of reality itself. I
Exactly.
mean, this event doesn't kill stars.
Yeah.
It fundamentally alters the laws of physics,
Yeah.
making atoms impossible and everything we know just cease to exist.
And today, we are undertaking a deep dive into the source material on this, frankly, terrifying possibility.
Yeah.
Our mission is to unpack how a fundamental concept in quantum field theory, the Higgs field, might not be permanently stable.
And how its collapse, if it gets triggered, would just spread through the universe at the speed of light.
Yeah.
Okay, let's unpack this, because this isn't science fiction, is it? It's a real possibility permitted by the standard model of particle physics. We have some incredible sources detailing the mechanism here.
We do.
And to really understand the danger, I think we first have to understand the foundation we're all standing on.
That foundation is the Higgs field. For anyone in the audience who might be catching up, the Higgs field is it's foundational to our understanding of the universe.
Wow.
It's an energetic field that permeates all of space and time.
I always ask people to imagine it like an invisible, thick ocean that exists everywhere. I mean, even in the deepest void of space, you are swimming in it right now.
That's a great analogy, and its essential function is to give particles mass.
Okay.
The more resistance a particle feels as it moves through this Higgs field, the more mass it acquires. So think of electrons, quarks,
They're all interacting with this field.
constantly. And without this interaction, they just zoom around at the speed of light, never bonding, and atoms, matter as we know it, would never form.
So it's not just a nice to have. It is the prerequisite for everything.
Absolutely.
It's the reason why the chair you're sitting on exists and why you exist.
Precisely. And this is where we pivot to the instability. Any field in physics you see, it settles into the lowest possible energy state, its vacuum state.
Okay.
And we assume the universe is currently residing in the lowest, most stable state of the Higgs field, which has allowed us to exist for billions of years.
But the sources suggest that assumption might be, well, fundamentally flawed.
It might be.
The energetic state of the Higgs field, the one that allows particles to have the mass values they currently have, might just be a temporary state of stability, not the permanent one.
Correct. And that temporary state is what physicists term the false vacuum.
The false vacuum.
And this is where we need to move past the abstract language and, connect it to a concrete analogy.
Let's use the famous one that our sources rely on. Let's imagine a massive mountain range,
Okay.
and the height of the mountain, the elevation, that represents the energy of the Higgs field.
Right now, the Higgs field's current state is like a golf ball sitting in a small, relatively shallow valley on the side of that mountain.
And that small valley is the false vacuum.
That's it.
And that valley is pretty cozy, right?
Yeah.
The ball has been sitting there for 13.8 billion years since the Big Bang.
Yeah.
If you nudge it slightly, it just rolls back to the bottom of that shallow valley. It looks stable. It acts stable.
And this is the crucial part. If you look down the mountain, beneath our little false vacuum, there is a much, much deeper chasm.
A truly vast, stable depression.
Exactly. That deeper chasm is the true vacuum. That's the lowest possible energy state the field could occupy.
So what you're saying is the false vacuum is stable enough for civilizations to rise and stars to burn for billions of years. But it only requires one thing to fundamentally change. A massive push over the small energetic lip that separates our current valley from the ultimate true vacuum below.
And this is the technical nugget for our deep dive. When we talk about the field state, we're talking about its vacuum expectation value, or VEV.
The VEV.
The false vacuum has a high VEV, giving particles their current mass. The true vacuum has a different lower VEV. If the decay happens, the field shifts instantly to that new lower value.
Okay, that makes the stakes really clear. The false vacuum is stable, but maybe not forever. It is susceptible to collapse if the right trigger appears to shove that golf ball over the lip. So what is this trigger? What provides that specific massive push needed to start the decay?
The required trigger is, well, Simple in concept, but extreme in scale.
Yeah.
A single particle interaction with an incredible concentration of energy.
Enough energy to locally tunnel the field from our state.
To the true vacuum state, exactly.
And we're talking about an energy level far, far beyond what even the Large Hadron Collider on Earth can achieve.
Yeah.
We need something naturally violent.
Yes.
So what are the potential sources for this deadly particle?
Well, the sources outline a few possibilities. One of the most straightforward is a highly energetic cosmic ray.
Okay.
These are particles, often protons, accelerated by extreme things like supernovae or black holes, and they travel through space at near the speed of light. If one hits the Higgs field with just the right and massive amount of energy, it could kick off the collapse.
And the second possibility is even stranger.
Yeah.
It doesn't even require an external entity. It could just be a quantum fluctuation.
Right. If you consider empty space, according to quantum field theory, it's anything but empty.
It's buzzing with energy.
There is a constant inherent fuzziness energy popping in and out of existence momentarily. This is the uncertainty principle in action. So if, purely by statistical chance, a sufficiently large and energetic fluctuation occurs randomly in space, that huge momentary energy spike could provide the quantum shove needed to push the Higgs field over the energetic lip.
That's a sobering thought. The end of reality could just be a statistically improbable roll of the dice in the void.
It is. And the third theoretical candidate is some kind of extreme event, maybe involving a primordial black hole or an exotic new particle we haven't identified yet, but which carries the necessary energy.
So whatever the source.
Whatever the source, if this particle appears, it forces the Higgs field at that specific point to instantly adopt the energy parameters of the true vacuum.
This is where it gets terrifying for me. A collapse is initiated at a single point in space. What happens next?
A bubble forms around that initial point of decay.
A bubble.
And inside that bubble, the physics has already changed. It is the realm of the true vacuum. What's critical here is the propagation speed. This bubble of new reality doesn't expand slowly.
How fast?
It expands outward at the absolute maximum speed allowed by physics, the speed of light.
Wow. That is the most brutal and instantaneous form of destruction imaginable.
It is.
Because the information about the danger is traveling at the speed of light, and the danger itself is traveling at the speed of light. There is literally no warning.
Exactly. You wouldn't see it coming, you wouldn't feel pain, you wouldn't even have time to process that something is wrong. Reality would simply stop. At the moment the bubble reaches you, the destruction is total and instantaneous.
And what exactly is destroyed? You mentioned that inside this expanding bubble, the laws of physics are rewritten. What does that mean for matter?
Since the fundamental state of the Higgs field has changed, the VeV is now different. All the fundamental constants that depend on it are altered. So particles inside the true vacuum bubble would suddenly lose the mass values they currently hold.
Wait, if the fundamental constants are changing, how far-reaching is this? Does that just mean everything is a bit lighter, or is the destruction structural?
Oh, it is structural and catastrophic. The mass relationship between fundamental particles, quarks, and electrons is incredibly finely tuned.
Okay.
If the mass of the electron or the quarks changes drastically, the forces that bind them together, the coupling constants, would just fail.
So atoms cannot exist.
Atoms cannot exist. Chemistry disappears. Stable nuclei fall apart. The variability for matter to hold itself together, which is all based on the current properties of the Higgs field, is dissolved behind the edge of that bubble.
Oh my gosh.
Furthermore, since the fundamental properties of space are linked to the VeV, time and space themselves would behave differently. In essence, the universe we know would simply dissolve.
It's the ultimate silent apocalypse.
Yeah.
So we've established the horror, instant silent dissolution. But this raises the most important question. Is this just a theoretical horror story, or is it mathematically required? Can this actually happen?
According to current quantum field theory and the Standard Model, yes, it is a physical possibility. But if you're asking about probability, that's where the conversation gets incredibly nuanced.
Right, because we have a powerful statistical counter-argument.
Yeah.
The universe has survived for 13.8 billion years.
That's the most powerful data point we have in our favor.
If the probability of collapse was high, it should have happened a long, long time ago.
Exactly. It means the likelihood of that specific high-energy particle appearing or that statistical quantum fluctuation occurring is incredibly low.
But low probability is not zero. Why do physicists take this calculation seriously enough to dedicate real research to it?
Because this whole concept is not science fiction. It stems directly from real-world, hard scientific data.
Well,
Specifically, the measurements of the Higgs boson mass taken at places like the Large Hadron Collider at CERN.
tell us what CERN measured that lets scientists put a number on our stability.
They measured the mass of the Higgs boson to be around 125 giga-electron volts, or 125 GeV.
Okay, 125 GeV.
And when physicists plug that specific mass, along with the masses of other key particles like the top quark, into the standard model equations, the mathematical result is, well, it's alarming.
And what does that 125 GeV number specifically tell us?
That specific number, mathematically, places our current universe not in the true vacuum, but precisely in the region of the false vacuum.
So it confirms the analogy.
It confirms the analogy. The calculation shows we are stable, but metastable. It confirms that the true vacuum, that deeper valley, does exist below us on the energy curve, just waiting to be accessed.
It sounds like physics is essentially saying, yes, the floor is definitely there and it's lower than ours, but the wall separating us is very, very thick.
That is a perfect way to put it. The energetic lip separating the false vacuum from the true vacuum is calculated to be extremely high.
So we're safe.
The consensus is that the probability of a particle or a fluctuation achieving the necessary energy is infinitesimally small. Our sources conclude that we are safe for now.
For now.
Now.
That phrase really captures the human experience of physics, doesn't it? It's truly humbling to realize that the most catastrophic threat imaginable isn't some external invading force,
Right.
but an intrinsic statistical fragility built into the very components that make us real.
It is the ultimate example of a risk where the foundation that supports us, the apparent constancy of physics, is perhaps the most fragile thing in the cosmos.
There's no external villain here.
None. The instability is in the Higgs field itself.
So if that statistical roll of the dice ever comes up, if that ultra-high energy particle ever appears, there will be no warning, no explosion, and no survivors.
The universe would simply continue, but the laws that govern it would be irrevocably changed.
Wow.
It leaves you with this provocative thought that we don't know the exact mechanism that created the fundamental constants we rely on, and that means the mechanism could change without notice.
The fragility of existence is just.
It's baked into the recipe, and the destruction, if it comes, will be silent, total, and irreversible.